We're going to be talking about the modern Java platform, not just the Java language. We'll talk about the Java language a little bit, but the platform, like the whole thing, like everything, all the pieces. And
in an hour and 30 minutes.
in an hour, yeah, exactly. Everything in an hour and 23 minutes.
That's right.
And we're going to be taking questions throughout. So if you have questions, just put them in the chat, and then Peter's gonna, or Courtney will interrupt us and convey your questions to us. So don't wait till the end, because we're probably not gonna have time at the end. And we told Peter that if everyone actually sticks around till the end, we're gonna actually dive into like Haskell. So
to make everyone leave.
To make everyone leave. It's like shutting off the lights.
Right.
Okay. Go wherever you want, but you can't stay here.
That's right. And with Haskell, you definitely don't want to stay. Okay, so modern. What does modern mean? My definition of modern is when something makes when something makes it easier to deal with increased complexity, which is, I don't even know if that's a good definition, but somebody asked me once, like, what does modern mean? Like, you're talking about like this thing is modern, and
it's the period between World War I and World War II where people thought that humans were still good.
Oh, that's modern.
Yeah, postmodern is after World War II, where they said, no, humans are not good. And we've been stuck
just
in
resources.
that forever.
Okay.
Yeah.
I guess that's one way to look at modern.
Yeah.
But how do we look at modern in the software world?
It's better than what we had before.
Better than what we had before. Exactly. So it's relative. It's a relative term.
Yeah.
And complexity just continues to increase. You know, we used to like, we were just talking at dinner how we used to like do Perl server. I used to do Perl web services, and you used to do C++.
No,
C.
My first
C
website was in C, and that was a mistake.
That was, I mean, it was hard, but in those days the complexity was pretty low compared to what it is today.
But you weren't trying to do that much.
Yeah,
you weren't able to do that.
You weren't able to do that much.
So we're able to do a lot more now, but that makes it a lot more complex.
That's right. And we've got all sorts of different constraints. Like things need to be more reliable. They need to be more scalable. They need to be, all those ilities. Those ilities have I think impacted our complexity level significantly. So modern is when a tool, a library, a language, whatever, makes it easier to deal with that increased complexity. So the important thing about the modern, that word, is that it's a spectrum, and modern can be a baby step from where we are today, can be a few steps from where we are today, or it can be some pretty gigantic leaps from where we are today. And tonight our goal is to show you a large spectrum, like the baby steps and then the giant leaps.
Right. Some improvements in the Java language, then a whole nother language which is better, then a whole nother language and language within a language that is better.
Yeah, and a whole different paradigm for how to think about stuff. But all on the Java platform. We're not leaving the Java platform. We love the Java platform, and we're staying there. But yeah, we're going to give you a whole spectrum. And if you're like, hey, that's too many leaps for me, then that's okay. Bruce and I have the ability to take some large leaps in languages that we use, and not everybody can take those large leaps, and that's okay.
And when you say the platform, do you mean like the JVM and hotspot, like stop there, or?
Well, we're going to even show some things that are not JVM and hotspot using Grovium. But it is all, I would say, under the umbrella of the Java platform. It is tooling that is OpenJDK or tangential to OpenJDK, like Grovium. So
super cool.
Cool. Okay, so let's just dive in. Let's dive into some code, because we like code. So let's start out with some Java code. So I'm going to go to we're going to start out with records. So in Java 17, we got a new feature called records, and
it actually appeared before that, but
like as a preview or something.
Yeah, I think it was finalized before Java 17, but it didn't matter.
I remember the xDoclet days where we would use a Ant plugin to generate Pojo, all the getters and setters from doc from Java doc. So like anyways, long ago.
Get back to the present.
Back to the present. So now in Java 17, we have language support for doing very concise syntax for things that just hold data, right? Is that what a record basically is? It's just something that.
It's a plain old, yeah, it's a data transfer object.
Oh, DTO, back to the,
yeah,
or value object.
Yeah, I guess
I don't know if I ever understood the difference between a DTO and a VO.
I don't know. It's maybe just different names for it. But the important thing is that it does all the things that you had to do by hand, or you had to bring in a third-party library to do. Basically, things like
Lombok or
so you get your equals and hash code and stuff like that, so that you can use it as a key in a hashed data structure. But a lot of time you don't even care about that. You just want something that holds data, and you don't want to have to mess around with it. I mean, one of the nice things about this is if we decided to add another dimension to our point, like Z, the record is going to automatically generate all that stuff. Whereas if you were doing it by hand, you would have to do it by hand.
Yeah, I mean, there's this constructor here that now is like, hey, you're not giving this thing a Z, so that's wrong. So,
but all the internal structure as well for hash code and
equals,
and these are
and two-string. There's like a fancy
two-string, right? There's a two-string. These are, there's no copy though.
There's no copy, which
is strange.
Yeah, that makes the ergonomics a little bit challenging, but I'm sure a library will fix that.
But the X and Y are invariant as well.
Immutable,
which is important.
Yeah, and so we've got this nice syntax now in Java 17, which is great. And I mean, this should be reason enough to move to Java 17. It's, if you're still in Java 8 like me, just, records are going to make your life better.
Well, it's an LTS release too, right? I mean,
yeah, and that's important to point out. 17 is the first LTS release since 11, right? And so it's been a little while. So 17, it's ready for you, and you should use it, and you should use records, because if you're using Java, they're so much better than, I mean, look at think of how many lines this typically is, like, and you can auto generate those lines, but for me, I look at that in about 35 milliseconds I can understand what is happening, what the data structure is. Whereas when I look at the typical Pojo with a bunch of generated code, it takes me a lot longer to parse that.
Well, and I think there's some hesitancy to creating a data transfer object if you think you have to mess around with a bunch of stuff. Whereas here, you don't really hesitate.
It's just like, hey, it's a record.
Yeah, that's what I need.
Cool. Good comment from M. Gitman. He says, I think Java records is being basically the equivalent of Scala case classes without the torment and temptations of Lombok.
Right. Well, and Kotlin data classes.
We're going to get there. We're going into Kotlin data classes and Scala case classes. There are some differences actually, and we're going to get into some of those, but records are awesome. Okay, so one of the things that we can do with Java, and do you remember what version that we added the
10 maybe
10 or 11 was the type inference?
Yeah.
So you're probably used to the typical syntax where you say like point, right? I don't even remember the syntax. It's like this, right? Right. And now we can just say var, and that's super nice because then we can rely on type inference. We don't have to. It's also
nicer with generics.
It's nicer with generics. Just reads to me like
well, you're used to it.
So. I'm used to it. That's true. Yeah.
And there's no val.
Yeah, it's true. But it's better than the type on the left.
Yeah.
So great, we've got type inference. These are immutable. So like if I try to set that X, like, hey, that's not going to work. That's a final thing. And immutability is like, I haven't written mutable stuff in a while, and I love immutability.
Even when I'm writing Python, I write in an immutable style. I assign things, but then I never change them.
Yeah.
Because there are benefits. Even just tracing back and seeing what did I do. If you're mutating things, you lose that information. But if you leave it alone, you don't. So
I can't grok programs that have mutable stuff in them anymore. Like it just is. I mean, it's really just a thing for me. Like my brain is too simple to understand the complexity of mutability in a program.
Yeah.
So I've gone like pretty much all immutable everywhere I can. And it's great. And it takes some getting used to, but okay. And then, we can print this thing. It's got a nice toString. One of the other really nice features in Java 17, I think is when this came in, was the multi-line text blocks. So that's a nice.
Lifted directly from Python, I will point out.
Hey, Scala, and I don't know who had it first.
Python had it forever,
like for 2 decades or something. I'm sure. Yeah. But yeah, this is nice. And this is nice.
But I think, I think people should lift good features, and you see it. I mean, Kotlin did it all over the place. That's all they, they only invented like one feature.
What was that one feature?
That was the extension lambdas.
Oh, okay.
Everything else was lifted from other languages after they've been proven.
I think we're gonna show extension lambdas.
Yes, we might.
Okay, now here's to the point about these records versus case classes and data classes. Here's one of the really cool things that they've done with records is that if you use a primitive array of records, then you get some really fancy memory compaction, where when it actually is writing these things to memory, it doesn't have all the overhead of the class information isn't duplicated for every single instance of this thing. It's really just the values that are written to memory. And so that's, I think, a really nice thing for when you use records and you have a lot of them, you're going to use a lot less memory. So that's a cool thing. I don't know. Should we even run this thing? Is it worth running?
No, I don't think so.
Yeah. Anyways, that's cool. Okay, we're going to run the next one though. Okay, so in this next one, to show off one of the other nice new language features, we're using records again. We've got a plumbus, a thing, and a meseeks. And the plumbus has a string, the thing has a plumbus, and the meseeks has a thing. So just a hierarchical structure of objects.
Composing,
that word means different things. So we now are going to create a meseeks 1 and a meseeks 2, but you'll see in meseeks 2 that our plumbus is null because Java still allows us to use nulls, which we'll talk about later. But
hey, James,
yeah,
sorry to interrupt you. You got a comment from Alex Buckley, who I think is on the JVM team.
Oh gosh, yeah. Oh neat. Oh geez, we've said something wrong.
we got a lurker here. So hi Alex, by the way, long time. So he says, I think you're confusing record classes with value types. Arrays of records do not get that treatment today.
They don't?
FYI.
That's funny, I thought.
Oh, okay. Well, thanks, Alex.
Minor retraction printed. Thank you, Alex.
Okay.
And nice to see you. Wow. All right, cool.
Thanks, Alex.
Sorry to interrupt you, buddy.
I thought that records had that wonderful treatment, but guess not. Okay.
Too many languages.
Too many languages to hold in our heads at once. Okay. All right. So, hey, we don't get that special awesome benefit, but with value types, we do. And do we know anything about value types in Java? I feel like I learned about them once, but I've forgotten it.
I'm blanking.
Yeah. Me too. Okay, so we'll go on to the null stuff. Okay, so nullability. So we, if we have our meseeks in a set, and then we're going to iterate through them and print them out, we probably can look at this code and expect what's going to happen here when we try to iterate that meseeks 2 and get to the thing.plumbus.s, the string in the plumbus. But let's actually run this thing and see what happens. So here we go. We get a null pointer exception as you expected, but now we get this nice error message that tells us, hey, could not read field S because it.thing.plumbus is null. So it actually tells you the path information about what was null and where the null was. So that is super helpful when you're dealing with nullability stuff. So yeah, so that's a certainly helpful improvement, which I'm pretty sure that was that added in 17. Maybe Alex can tell us. We've got the experts here. Can't keep track of all the versions.
It's been a while since. So I added all this stuff in on Java 8 because the Chinese translation, the Chinese publisher wanted me to add all the things. So there are sections that describe all the intermediate features. And I put the numbers where they were introduced there, but I can't remember. That's why I write books. Is
Yeah.
to,
You just
then I
write
can-
it down and then you can
and
look
then
back in the
yes,
book
you can
to,
look back at
yeah.
it. Yeah. So that'll be up in the next couple weeks, I think.
In English
Then
as
you can
well
hit
as
Control
Chinese.
F, and then you can hit Control F and search through the book. Oh wait,
Yeah,
You,
because it's
if you,
only an
yeah,
ebook.
if you, oh, it's only an ebook.
It's too big.
Yeah.
Yeah.
Like how thick would it be?
Oh, I have no idea. I have no idea. It'd be over 2,000 pages.
Wow.
I think. Yeah. Yeah. It's too big.
This is thinking in Java.
No, this is
No.
on Java 8.
On Java 8.
Right.
Okay. But on Java 8 now covers all the way to 17.
Well, the bulk of the book is about Java 8, but then there are these sections that say, here are these new features.
Okay.
So that's how I had to, because there's still a lot of people who want to.
Yeah.
Spec lead footnote: helpful NPEs appeared in Java 14. FYI.
Yes.
There we go. See?
It's great to have the experts on.
Yep.
Okay. So let's talk about pattern matching. So let's make this one a little bigger. So one of the things that we've seen appear in a lot of modern languages is what's under the banner of algebraic data types. And there are primarily two algebraic data types that people use. There are product types and there are sum types. And we're going to look at sum types since Java 17 added support for essentially doing sum types in Java in the language. And what a sum type is it follows algebraic rules, and that's why it falls under the banner of algebraic data types. But it allows us to define a data type with specific instances of that data type and limit those instances to a specific set. And so in this case, what we're saying is that we've got a sealed interface transport, and then we are going to have 3 records which implement that transport. And
the sealed keyword is the important thing here.
The sealed thing is the important thing. Don't you have to say permits or something on this?
No, only if they're in different files.
Oh, so if it's in the same file,
if it's in the same file, yeah, that's why this compiles.
Okay.
Yeah.
Nice. Okay. So so we are creating a algebraic data type, a sum type, which is our bicycle, glider, and surfboard are our transports. And because it's sealed, you cannot extend or implement transport anywhere else. So the compiler knows that there will only ever be a bicycle and a glider and a surfboard for transport. Mm-hmm. And this gives us some nice benefits when the compiler exhaustively knows what the possible implementations of something are. And what else do you want to say about this, about the sealed interface?
Well, one thing to notice is that each record has its own different property or field.
And this is why it's different from an enum.
Yes, right, because you can do things like this with an enum. You can have constructors for enums and things like that, but they all have to have the same constructor. So whereas here, I mean, records in general, the important thing about the record is that we have different properties in it. So each one of these is different, and that's the kind of compelling reason to use pattern matching in this case. So what we're looking at here is now, and I should point out that this is still a
the pattern matching.
The pattern matching itself, all the other features are part of 17, but this is a preview feature, so it's not finalized, and it's also fairly limited at this point. I think right now it's just switching on types.
It's just like the is instance of.
Yeah, it's just kind of doing an is instance of, except that they use some strange nomenclature for this, which we'll just ignore. So if it's a bicycle, it creates a new identifier B which has the type bicycle. So now T has been converted into a B, and so now I can just use B, and notice that I can select B's ID, which is different from glider size and surfboard's weight. So that's kind of the reason that you'd want to use a pattern match here, is because you're doing something different for each different type, because they differ that way. And they're all, you know, we're only accepting transports here. The other thing to notice is that what they've done is overloaded the switch. So now we have the ordinary switch, which you're used to, and on top of that, there's this pattern matching ability. And notice also that we're returning the result of the switch expression, because switch is now not just a statement. There's both. You can have a statement and an expression. It's all a little bit confusing. I probably would have done it differently. So switch now returns an expression, or returns a value. So, and now the other thing to notice is that we've got the arrows here. We still can have colons. So you can have, with a switch, you can either have colons or you can have arrows. Again, I probably would have just created a new keyword instead of overloading switch, but this is what they did. And then what the arrow does is it says, here's the result of the switch expression, and the implicit is that it's also, you don't have to put a break in there either. So it's a much nicer syntax. The other thing that was added was that you can have a null case, which is a new feature in a switch. We didn't used to be able to go for null, but even though nulls can always happen, you're
in
not
Java, everything is
in
nullable,
Java,
so.
everything is nullable. So it's unfortunate, but this is historical, that you're not forced to put a null case in there. So you can still
Get a null pointer.
You can get a null pointer exception. Now, if they had added a new keyword, they could have, but I mean, you couldn't all of a sudden say, okay, now you have to cover null, because that would break tons of code. So, but if they had instead put in a new keyword for pattern matching, then they could have insisted on a case null. And so that's a little unfortunate, but
I want to try one unrelated thing.
Sure.
So we can,
Nope.
oh no.
Nope. You have to do it with,
you have to do it through the accessor.
Yeah. No, you're thinking of Kotlin.
Oh.
Because the Kotlin example is that way. Yeah. So then down here, we just create a list of is a newish way of creating a list. It's a more succinct way, and you'll see that it might have been inspired by Kotlin. So we create some
nice syntax for creating a list.
Right, and then for each we pass it to our function exhaustive, and the rest of it's just showing, yeah, okay, well, it seems like it's exhaustive, but it's not really, because it still has nulls.
Not exhaustive with the null case.
Yeah.
Okay. Do you have the ability to go add a new record that implements transport? You've got skis down there.
Yeah. So we could.
We're in the mountains, so let's add skis.
So if we add skis here, you can see that somewhere up here. Oh yeah. Okay. Right here, we see switch expression does not cover all possible input values, and it's possible. Okay. Now I think. How do I get this to?
Oh, we can do Alt Enter and then say, oh no, it didn't. It did for you when we were testing this.
It did. Well,
yeah.
I had to do more actions. Not okay.
I don't know how to.
So let's see. It's possible to do it, but I have to
more
get over
actions.
that. More actions.
No, it's not doing it this time for some reason.
Well, that is weird.
IntelliJ is confused.
Okay.
IntelliJ did earlier today show us.
Okay,
that
but
they
anyway,
could
it tells
insert
us
the
that
case.
now we have this new type, and we haven't covered all possible input values for transport. And
Yeah.
so that's kind of the point of
Of a sum type.
yeah, right. Is that
Yeah, I think that one of the huge values of sum types is the exhaustive pattern matching, and this is still experimental. The
in
exhaustive
Java?
the pattern
Yeah,
match on
and
the,
future pattern matching will presumably include all, some other of the fancy things that you see in languages like Kotlin and Scala, and actually Python has pattern matching now too in version 3.10. So yeah, and if you want to slide the thing, this.
Yeah, I was thinking if
there
there was anything else that we wanted to show there.
No, I think that's enough.
There is another syntax we're not showing here, which is the is instance of with the it's like the one that is official in 17, which allows you to, in one statement where you do the is instance of, create the
but
the B2.
that was only to support this.
Yeah,
that was just an intermediate.
I could see
step
maybe
to
some
support
people using that.
I don't see that. So yeah. So and
all right,
here is and the link at the top is the GitHub repo that has both examples in it.
This is now over into Kotlin, which is going to look really similar. Instead of a record, we have a data class. You can put mutable values in data classes, so you have to tell it you want a val, which isn't a mutable one.
And we don't need the empty curly braces.
No empty curly braces. You need the colon instead of extends.
Right.
So that's a little bit different of the syntax, but
yeah.
So, but this creates the same sum type, the same ADT as we saw before.
It does.
And then
and notice that the function is a top level function. It doesn't have to be inside of a class. Then you'll, oh wait, we forgot the semicolons. How come this is compiling? And
you really hate semicolons.
I do. If somebody
Python doesn't require semicolons.
Of course not.
Right?
Yeah, somebody shows up with a new language, and this has happened, and they go and they have semicolons. I go, semicolons, really? And they go, yeah, semicolons. Suck it up. And I go, nope, not gonna.
You're
not like, gonna. No, semicolon.
Your language is dead to me already.
Yeah, if it has semicolons in it, it's just
yeah.
So instead of what we had in Java, we use when.
Yeah.
And when is the pattern match, and here it's saying is this type. And notice that it doesn't need to do that
identifier thing.
Yeah, it doesn't need to create the identifier. It just turns T into a bicycle or a glider.
So this is, and IntelliJ is showing us with the green there that T is being smart cast.
Yes.
It's called a smart cast.
It is called a smart cast. And this part on the left of the arrow can be a lot of other things. Regular expressions or anyway, there's a whole bunch of things you can do with pattern matching.
Not just a type.
Not just a type. And Java is going to add more, but I have no idea how far they're going to go. It doesn't seem likely that they're going to be able to implement all the things that you see in Kotlin or Scala or Python. So that's just a guess, though.
Quick comment from Alex that seems quite relevant.
Oh, Alex is going to be badgering us this whole time.
Go ahead. Yeah, I love it. This is great.
Introducing variables into patterns is invaluable when you have nested patterns. End quote.
Nested patterns. Yeah.
Okay. I don't know.
I don't ever nest patterns, but
yeah. Okay.
But yeah, okay. Yeah, I get it.
Yeah.
Cool. Okay, so let's see. We've got our Kotlin one, which looks pretty similar and does the pattern match on the type. Let's do the add the skis to this one.
So if we add the ski data classes, you'll see, okay, now this time it shows up at the when, and it's telling us exactly what to add. In this case, oops, come on. I have to be really
Oh, it's my computer is impossible to use.
No, and I'm a
No,
little bit.
it's
Okay, so it can say add
No.
remaining branches, and
ooh,
so it goes ahead and adds the
match for
is
skis.
skis
Yeah, and then we
to
can.
correct it.
That's cool.
And then
cool.
the other thing that can happen is if we were to say that this is a nullable type,
Oh, so
then
if transport is nullable,
it
that's what that
says
question mark means.
add necessary null branch. Okay, so if we add the else branch, well, else branch, or it
We
can
can
have
also do the null one.
we can, yeah, here, you
That's
do
really,
it because
yeah.
I'm a little,
Yeah, it's
there, you
let's.
can do it.
It's
Add else.
my computer.
No, add remaining branches.
Add remaining branches. There we go. So
There
now
it
we
is.
got the null
Okay,
case.
so
That's cool.
there's your null case.
Yeah. Yeah, so that's the exhaustive pattern matching. So, and what's cool about this is that if we don't have those, then it's going to be a compile error because, and that's the cool thing about some types is that we can do this exhaustive pattern matching and get compile errors when we don't match on all the types.
Right.
And I've certainly had bugs where I missed one of the possible cases or possible types that something could be. So
yeah, and the fact that we have to if something is going to accept a null, we have to explicitly say it by putting that question mark on the type. That is really important because it says that without that, we're, this is not correct code.
And it's not exhaustive.
Yeah,
and you're going to have bugs.
Yeah, you're going to have, but it prevents you from handling the null. I mean, it prevents a null from happening at all, ever, unless you say explicitly, oh yeah, this function can accept a null, in which case then you have to handle it.
Yeah.
So it doesn't just escape and go flying all over your program, breaking things.
Right. I changed your syntax from what you had originally. So I don't know if you want me to talk about.
Okay.
Here, let's play a game. What is my code doing? What is my change?
Well,
to your code doing?
you're mapping the you're applying the exhaustive function to everything in the list, and then you're applying the print line to everything that comes out of the map. Yeah. I don't
know if that's more readable than what you had, but
I was probably using it or something. Oh, yeah. No, that's
so
that's okay.
We can go back to what you had because it's kind of a fun thing. So what you originally had was it dot actually no was let's call it exhaustive. Oh no, println. We're embedding things, so in println, and then the exhaustive, and then the it, which is the reference to the item.
If there's a single item coming out of the list, then it's
on
inside of a lambda. It's just it. Yeah.
I don't know which is better.
Oh no, I probably like yours better. Yeah, I tend to prefer the.
It's the using the method handles or something. What do they call
method
those?
references?
Method references.
Well, function. We don't
references.
use the term method in Kotlin.
Oh right. Yeah.
You say member function or just function.
Yeah.
In this case, it's just a standalone function.
Yeah.
So.
Okay. So there is.
I want to plug my book.
Yes.
Atomic Kotlin. So if you go to atomickotlin.com, it introduces the whole thing.
All about all these things.
Yeah, and we tried to make it a really gentle introduction. So that's enough of a plug.
Okay.
On we go.
Okay, on we go. So we've seen some types, we've seen records, and we've seen data classes, and we've seen some stuff around nullability. We're going to get a little bit more into nullability in a little bit, and some other nice Java features that are great, like the multi-line string stuff. And so let's take it a step further.
Okay.
I'm going to actually just start from scratch and create a brand new application with Spring Boot. So of course, Josh Long has taught me to go to start.spring.io, and I'm going to do a Gradle project and Kotlin, and I'm going to add some dependencies in here. I'm going to add in the Spring Boot dev tools, and I'm going to add in the web flux stuff. Web flux. Oh, reactive web. Oh, there it is. Okay, and then let's hit this generate project button. I've got my demo.zip with my project, and now I am off to the races. And let's see where we can go with this project. So let's go to my projects directory and let's unzip. And I'm in WSL, so I need to figure out what my path is to my user on where this downloads thing went. There it is. Okay, I've got my demo project. Let's go into that thing. And I need to always be moving this this menu around so that I can see what's underneath it. I don't know how to dismiss that thing in Zoom. You want to try? Hide. Oh, there it is. Hide floating meeting controls. Yay. Okay. All right. Yay. Now I can type freely.
Don't hit escape.
Okay, we've got my fresh spring project, and let's go now open this project up. So here's my demo project. Let's open it in IntelliJ. And what we're going to build is going to be a Kotlin Spring Boot application, and this will give us a way to explore some language features in Kotlin that that I think are pretty cool for doing async and null handling and some type inference stuff. So, okay, so we're importing that project in. We've got, let's go look at our Gradle build. We've got Spring, we're bringing in. We've got dependency management. We've got Kotlin, we're bringing in. Oh, Kotlin 1.6.0 was just released. And so we need to get the update to start.spring.io in there. So we've got dependencies on Webflux. That's our reactive. We'll talk about in a little bit. We've got our Jackson Kotlin module Kotlin for doing our JSON serialization and deserialization. We've got some extensions, some Kotlin stuff. Okay, but let's go actually get this thing up and running. So I'm going to do my Gradle W-T classes. And this actually, I think, captures some of the great things that are happening in the Java ecosystem, is that I'm going to run Gradle. And Gradle is going to, with that -t, be continuously recompiling the classes. And so in the background, it's just going to be recompiling those classes.
Is that new?
It's been around for a while. SBT was the first Java build tool that I saw do this, and other build tools have it as well. So it's not novel. It's just like, for me, it's like awesome in the to have this tooling in the Java ecosystem, and it works pretty well. So okay, let's go back to here, and now I'm going to run boot run to run my Spring Boot application, and let's get this thing up and running. So for me as a developer, I focus a lot on how quickly I can iterate on code, and this what I'm showing you with Spring Boot and Gradle, this continuous recompilation, reloading, really makes me more productive as a developer, and I think that's a great thing in the JVM ecosystem, and not exclusive to Gradle and Kotlin in any way, but definitely something that's improved in the Java ecosystem as a whole. I think the one that's actually done this the best is Quarkus. They have a great developer experience around auto recompilation and reload. Okay, let's go see if this thing is working. Yay, a white label error page. That's exactly what we wanted to see, because we haven't actually added a handler yet for our application. So let's go back into IntelliJ and let's open up our Kotlin demo application KT file here, where we've got our Kotlin file. We've got our main function. One nice thing with Kotlin is this doesn't have to be in a class. It just can be a free-floating function main. It takes its arguments, array of string.
You don't actually even have to have arguments if you don't use them.
Oh, that's a good point. We do pass them into Spring in case for some reason we didn't need them, but you are right, we don't.
But once you see that, you go, oh no, I've been typing this all the time in Java, and I didn't really have to.
Let's just delete that. We don't need that, right?
I don't know.
Yeah, I think that'll work just fine. We'll see. And with our automatic recompilation, hey, looks like it worked. No compilers. Cool. Okay. So we're running our application, demo application, and this is going to be a REST controller, right? You all have probably written these before. And now we can write our basic REST controller, but this time in Kotlin. It's going to look a lot like the Java, which is nice if you're coming from the world of Java. I'm going to create a Git mapping, and I am nowhere near as good as Josh Long at live coding, so bear with me. But we've got our Git mapping for slash, and then we've got our Kotlin function called index. And let's start by just returning a string. So now I can say return hello world, and hey, no semicolon there. You like that? That's nice, huh? Yeah. Yeah. Okay. Let's go reload this thing, and it's reloading the server. There we go. We see our hello world.
Wow.
What did semicolons ever do to you, James?
Yeah, I don't hate them as much as Bruce does. Are they optional in Kotlin? Can it?
Oh yeah.
Oh, they are optional.
Well, but notice it grays it out immediately.
Yeah,
and gives
it's
you
like-
a little
it's
light
like-
bulb that says you don't need this.
You're doing this wrong.
Yeah.
Yeah. Okay, so we've got our function. I want to show you a little bit different of a syntax for doing this. I like to use type inference wherever I can. And so I'm going to say, all right, this function index, let's actually just call something called run. And that's in the Kotlin standard library. And now we're in a Lambda. And in what is that called? A Lambda? Yeah.
Yes.
And in a Lambda, the last expression gets automatically returned. Is that right?
Yeah.
And I don't know, that looks nice to me. I like that. And it infers the type. So I can come in here and put in like, hey, let's have a string in here. Oh, what's funny is that every time I hit escape, it pops this menu back up.
Yeah, and then it'll tell you press escape to show floating meaning control. So it's doing
so
what,
don't hit escape.
Yeah, don't hit escape.
Yeah. Okay, so I can put in the type here, or it can just be inferred.
So what does the run do?
What does run do? Run is a function in the Kotlin standard library, which takes a block and just runs it.
Oh, can't you just say equals the string? Why do you have to?
Oh, you can, but I'm going to do more stuff.
Oh, okay.
And so I need the
You need
lambda.
multi-line.
Yeah, I need multi-line.
Okay.
Yeah. Okay. Now this is cool and it works. I think we tested that it works. Let's double check that it works.
Still says hello world.
Hello world. Still says hello world. That's good. Okay, but now let's do something a little more exciting. Let's go reactive. And so
what does that mean?
What does that mean? So reactive is in some ways about being non-blocking. Non-blocking is about typically what happens in a mostly Java applications is that we've got threads. And when we, let's say, do some IO, like we make a request out to something, and the whole time we're waiting for that thing to come back, that thread is occupied. It's in a wait state or whatever.
Locked.
It's allocated, and
it's a resource that's not being used.
It's a resource that is allocated but not being used, and that is just a waste. And so what we want to get to, ideally, for better performance, better memory usage, primarily, is to be non-blocking, where we make the request to something. In the case of a request, that's an easy thing to be not blocking on. We make a request to something, and when we're just waiting for that thing to respond, we actually deallocate that thread and let somebody else use it. And threads are kind of expensive, so we let somebody else use it. And then when that response is coming back through TCP, then we revive or get a new thread and then can actually process the response.
Okay, in the old days, we used to call this concurrency.
I think it is only useful in the construct where you have limited resources and you want to concurrently use those resources. Yeah, I think you're right. So and typically in a server application, we do have many requests coming into the application. We want to be able to handle those.
If you're a popular server.
If you're right, yeah, that's right. I mean, if you're unpopular and you only ever handle one request at a time,
you can just write it in Perl.
Then write it in Perl. You'll be fine. But ideally, the best usage of our resources is to be non-blocking.
Okay.
And we should probably take a little side vent to Loom, which I have not used yet, but Loom gives us
Does it exist?
It's in progress.
Okay.
Yeah. Loom gives us the ability to go back to something like green threads, where our IO APIs use something very lightweight, so they're not actual threads that are being allocated and
With their
blocked
own
essentially.
heaps and
Yeah,
stuff.
with their own
Yeah.
heaps and stuff. Yeah.
Mhm.
Yeah, and so, but for today, before Loom, before the world of Loom, we have this ability to, we should be non-blocking because it's the most efficient way to manage our resources. It also maximizes thread contention on CPUs and some of that stuff. So if you have, let's say, 1,000, 5,000 threads in your system, there's going to be a lot of contention on your actual CPUs, and that's kind of wasteful. So ideally, the most ideal way to be is to have the same number of threads as you have CPUs on your machine. That's usually the most ideal
Or minus
scenario.
one.
But yeah, or minus
It's
one. So you've got some
very
systems. Yeah, a thread.
And of course, are we talking about the actual cores, or are we talking about hyperthreads?
With cores, yeah,
Yeah.
yeah. So we've got that's the ideal. It also preserves CPU caches, and there's good reasons to be non-blocking and all that. Okay, so let's go non-blocking. Here's the easiest way to do it: is I'm going to use a function called delay, and this is kind of like thread.sleep. I need to import it here. Let's go import our delay. Not that button. This button. I hit escape again.
Yeah, man.
Well,
okay, so you did the import.
Okay, so I did the import. So now we've imported delay, but still IntelliJ is not happy. And the reason for this is that Kotlin has built into it this concept of coroutines, of something being asynchronous. And a lot of times we're familiar with asynchronous stuff from having to do callbacks. It's like, okay, when this thing completes, now I'm going to give you a callback to process the result when it comes back. Kotlin gives us another tool to handle this asynchronous stuff called coroutines. And in coroutines, when we do something that is async, like delay or like calling a web service, we then need to tell Kotlin that, hey, I'm calling something async, and that propagates through our call chain. And so it's telling me that, hey, your function that is doing this async thing, it also needs to be marked as async, and you mark it as async by adding suspend. So now index is a suspend function called index. Now, if we save this thing and go back to our browser, let's pull up the network inspector so that we can see here making a request. And we can see that this request took 1.09 seconds. So there was a little bit of overhead to the request, but it did that delay for a second and then returned the result. And in that 1 second that it was doing that delay for, there wasn't a thread actually allocated to this particular function. So the code looks synchronous. So if we look at this code, it's like, all right, we do this thing and then we do this thing. It looks synchronous, but Kotlin actually takes this and turns it into something that can happen asynchronously.
So delay suspends the coroutine, but when you put the suspend fun around it, I'm assuming that it hooks it into your scheduling mechanism.
Yeah, exactly.
Yeah,
this is based on,
it gets
on
suspended.
Netty, which is Spring has support for Netty, which is non-blocking IO. So there's this whole chain of things to handle the asynchronicity of this. And Spring Boot has support for the suspend functions in Kotlin. The
scheduler figures out when it's time to resume this coroutine.
That's right.
Which is when the delay times out.
That's right.
And then it goes, oh, it's ready to run again.
And then we go on to returning hello world, and then that gets serialized into the HTTP response.
Okay.
Yep. Okay, so in your code, you're hopefully not going to use delay as a thing to not block on. So I think we should take this code example and make it something more useful, and that'll be making a web request out to a service, and we can make that request be non-blocking. So I'm going to use the GitHub API, and I'm going to make a request to this GitHub API to get the Kotlin tags, which is a list of the releases. And so we can see here the list of Kotlin releases in JSON form. And let's copy that URL because we're going to use that. Now let's come in here and I need to set up some stuff. So in Spring Boot, there's something called a web client, and I'm going to create a web client. And the web client is a non-blocking HTTP client. So we're just going to create an instance of that thing. And then I'm going to create a field to hold our URL and paste that in there. So that's what we're going to make the request to. So now instead of not blocking on a arbitrary delay, let's now make a request to this service. So let's call our web client. And then I'm going to do a get request and I'm going to give it the URI, and that's going to be our URL. And then I'm going to call .retrieve on this. So .retrieve is actually the point when we go non-blocking. What we get back from retrieve is this response spec. And response spec is actually a mono. And for anybody that's used a reactive API like RxJava, or this one is reactor based, or this could be futures in Scala, or a promise in JavaScript land. This is our non-blocking construct, and this gives us the ability to do that asynchronicity. And Spring Boot we could just return the mono, and that would work fine. But I'm in Kotlin and I want to use coroutines. So there's actually a way to convert this mono to a coroutine, and that's by calling this await body. And so when I call await, await body, I need to actually parameterize the await body with what I want to deserialize this thing into. And I need to deserialize this data into something. I'm going to go and create a data class called our releases. And I'm going to put a value in here called name. And that maps to here. We see in our response, we get a list, and then we get these JSON objects, and then there's a name property on each one. So now let's deserialize this thing into a list of releases. Okay, so now my suspend function index is going to make this HTTP request to the GitHub API, and when it gets a response back, it's going to deserialize it into a list of release.
But wait a minute,
that's just
it's a JSON thing. How does it know to put that first field into your single argument?
That's the magic of Jackson. The Jackson JSON library is doing that all for us, and it'll just work. It looks at the parameter name called name.
So it does it by name.
Yep.
Okay.
Yeah, and so let's actually go give this thing a try and see if when we make our request, so you'll see my browser is spinning, the request is open, but there was a time there where there were no threads allocated to the request coming into my server or the request going out to the GitHub API. We were just in a, hey, we're not consuming any threads, we're just waiting for that response to come back. And then we get the response back and we deserialize it into our release object.
But it's still JSON.
It did come back as JSON because what was returned by this function was a list of release, or is a suspend function that returned a list of release. So we could actually put in the type here. It's just a list of release.
Okay.
Right. Escape. All right. So that is, and if I do put it there, then I don't actually need it there. But anyways, so that's what this is returning. And Spring Boot knows that if it gets an object, then it just is going to serialize it into JSON. It just does that for us automatically.
It doesn't seem to think you need index.
Yeah, it doesn't know that that's being used.
Okay.
Okay, so let's go a little bit further with this thing. So we're now reactive, and that's cool. Let's set this to a value called releases. And now what I really want to get to is the latest release of Kotlin. So let's take our releases and let's do some stuff on our releases. So let's first do a filter. And this is one of the cool things we showed a little bit of before, but I'm going to do a filter not. So I'm going to filter out everything that doesn't match this predicate. So I'm going to say it.name, and then I'm going to do a contains of dash there, because if we look back at our list of releases, I don't want the RCs and the milestones. So my easy way to handle that is just to remove the ones that have the dash in them. So that's just a nice, concise syntax for
Can
being
we
able
see
to
the
do.
result of that now?
Sure.
Okay.
Yeah, let's see the result of that. Let's go reload this thing, and we should see the list now without without the dash ones once it loads. There we go.
Okay.
Okay, now let's go a little bit further. Let's get the first or null. And the reason why I want to get the first or null is that what if I had filtered everything out of my list
And
I
list
can't
is
get
empty.
yeah, the list is empty. Well, if I just call dot first on this thing and the list is empty, then I'm going to get a null pointer exception. And I don't want a null pointer exception. So I'm going to say, give me the first or null. But then I've now got a nullable, right? And so my return type now is going to be a release question mark. So it's I can't return, if I try to return an actual release, it's like, hey, no, you aren't handling the nullability. And that's the nice thing here, is that we're being forced to handle nullability, and that's a good thing. But we can actually chain operations with the nullability. So to do that, I want to get to the name property on release. So I do question mark dot, and then I do name. And that says when the thing that I got after calling first is not null, then I'm going to get the name property there. But what I get back from doing this is going to be a nullable string. So we can put in the type there is string question mark. If I try to say this is a string, it's like, no, this is still, you're still in nullable land. You haven't done anything to deal with the nullability. So let's actually do something to deal with the nullability of this thing. And what I'm going to do is give it a default. So I use this Elvis operator.
And you hit escape.
Yeah, and I hit escape again. Okay, so the question mark colon is the Elvis operator, because if you tilt your head, it looks like Elvis.
There's that, and it's also sort of like else if.
Yes, like else if. Yeah, that's right.
Yeah.
Well played, guys. Nice.
Okay, so let's return our default case. Now it is going to, the value of this is just going to be a string. And if we reload this, then we should see that our latest release of Kotlin is 1.6.0 once that makes that reactive request out. And there we go, 1.6.0.
And it's now no longer in...
And if we make our filter so that it filters everything out of our list, and we go back and rerun this thing, then what's it going to output? Our default, right? Because it was nullable, because we didn't have a first anymore, and there it's hello world. So the explicit nullability, super nice modern language feature that helps us avoid null pointer exceptions. And yeah,
I've heard of people wanting to switch to Kotlin just because of the null handling.
Yeah. And no pointer exceptions in production are definitely no fun. And when your language kind of forces you to deal with nullability, it's a good thing. Okay, let's move on from the Kotlin code for a minute, because I want to talk about some of the other cool things that are happening in the Java platform ecosystem related to containerization. So I've got my application here, and I want to turn this thing into a container, a Docker container. And so to do this, Spring Boot has built-in support for containerizing this thing. And I'm going to do it through Gradle, because that's what I'm using. I'm going to say boot build image is my task. And let's just try to run this boot build image task here and see what happens here. So Spring Boot has built into it support for something called build packs. Build packs are a Cloud Native Computing Foundation, I think, incubating standard, which knows how to take lots of different types of source code, whether it's Gradle, Maven, Python, Node, Go, whatever, and turn it into a Docker container that is well layered, has good security practices, all the things that you may have to do on your own in a Docker file, you can just use from build packs. And so when we run boot build image, it's now using build packs, and it's using, in this case by default, the Paketo build packs to turn this source code into our Docker container image. So this is a great thing for the Java ecosystem. no matter kind of what build tool you're using, what language you're using even, you can easily turn your source code into a great container image with build packs. So there we go. It ran. There's great caching support in build packs as well. But now we've got our Docker container, and of course we can run this thing if we want. I need to actually not be listening on port 8080 over here, but let's go run our Docker run, and then we'll create the interactive terminal, run connect port 8080 into the container, and our container name is demo. So let's run that thing. Oh, why didn't I find? Oh, because it has a version. Let's specify the version here. Dash snapshot. There we go. Okay, so there we go. We have now run our container image. It started up our Spring Boot application. And now if we go to localhost 8080, I don't remember if I took that, if I put that dash back in, or if we're going to get hello world. Yeah, I forgot to put that dash back in. So we're getting just our default hello world, but that's okay. We've got our application now containerized, well layered, and ready for deployment on Kubernetes or Cloud Run or wherever you want to deploy your containers. And that's pretty awesome. So I think that's, one of the great things that the Paketo build packs do is that they give you great JVM memory settings just out of the box. So you don't have to think about what JVM memory settings would be good for you based on your container and how much memory it has. It just does all that stuff for you. So that's a nice thing that the build packs do for you. And I didn't even have to think about how to containerize this thing. It's just like run boot build image. There are other ways to containerize JVM applications. I think when somebody is entering the waiting room, it pops that thing back up. Yeah.
No, just
yeah.
Okay.
So build packs and the Spring support for build packs is awesome. You can use the build packs without Spring, and I do that all the time as well. But I think that's really a great part of the JVM ecosystem and improvements there. Okay, now let's switch gears to Grovium native image. So what you may have noticed when I ran this application, let's see if we can scroll up through this and see, is that starting this application took almost 3 seconds to start that thing. And actually, when I run this thing on the cloud, let's go, I've got this application up here and running, and
Jamie,
go ahead.
Sorry.
Yeah,
just
no,
super,
thanks for
super relevant on this one. And do you prefer build packs over Jib or Kaneko?
Yeah, good question. So there are different
from Ted.
Awesome. There are different ways to containerize applications. Jib is great. One of the nice things about it is it doesn't require a local Docker daemon to run, and so that's nice. But the Jib is only a JVM based build tool, whereas build packs are polyglot. They can run against almost all different types of projects. And so I use Jib sometimes, I use build packs sometimes. We're diving now into Grovium, and Jib doesn't yet, as far as the last time I looked, have support for Grovium native image stuff. And so that's one of the places where I tend towards build packs. Build packs are also a great kind of out of the box experience. I don't even have to do anything. I just run pack build or run boot build image. So there are definitely trade-offs. I haven't used the other one you mentioned, Kaneko or whatever it is. So I don't know much about that one, but yeah, it's, there's a little bit of trade-offs to everyone, to all these different options. Ultimately, don't use Docker files anymore. Like there are so many better tools than Docker files out there. So use something other than Docker files is really my recommendation on that front.
Yes, I never got good at Docker in the first place, so now I can just forget anything I learned about.
That's right. And we're going to talk in a little bit about test containers, which is a whole nother level of all this stuff too. But okay, so I've got my that application we were just looking at deployed up on the cloud, and I've only allocated a single CPU, so it's going to start a little bit slower. But if I go and actually make a request to this thing, it's going to start spinning. I have used Spring Native and Grovium native image to take the same application and turn it into an ahead of time compiled application. And I'm going to go make a request to that one. And what I want to show you is the startup times for these different versions of the application, and we'll talk about what it is. So my JVM based one is starting up, and we will see in the logs here in a second how long it takes to start this thing. There we go. So it took total total startup time for the JVM running about a little over 15 seconds to start up that. And there's only a single CPU allocated, so it took a little bit longer than normal, but there we go. We see it working. Now I've made the request to this other one, and that one is Spring native, Grovium native image applied, and you'll see my total startup time on the single CPU is just over a second. So significantly faster startup time, also a lot better memory usage out of the box. So what's actually happening here is that Spring Native and Grovium native image are Spring Native does ahead of time compilation on my Spring application, and then Grovium native image takes my JVM based application and turns it into a native application. So it ahead of time compiles it. So instead of running on the JVM and using the JIT, it's ahead of time compiling this application, and this means that I get much faster startup time, much better memory usage characteristics for this application. So if you're in a auto-scaling environment where you need to be able to start up quickly, then this is a great approach for reducing your startup time, reducing your memory usage, and that sort of thing.
And we have an interview with someone from
on our podcast, Happy Path Programming. We just talked to Alina last week. Yes, and learned a lot about Grovium.
Yep.
In that podcast episode.
So if you want to know more, you can listen to that.
Plug on our podcast. So I think this is one of the super exciting things happening in the world of modern Java is Grovium native image and the ability to ahead of time compile applications for serverless, also for CLIs, the ability to have a CLI that's built on the JVM and starts up instantaneously is super awesome. And so in the case of this application, there was only one little configuration change that I needed to make this all work. And this is, in my case, in Gradle, I am telling the boot build image task that I'm going to use the Paketo builder tiny, and that just reduces my container image size. And then I am telling it to use the native image when it does the build.
All right, guys, I got a tough one for you.
Okay.
All right, here we go. We got a really good question. And I'll tack one thing onto the end of it, which you can choose to take the Fifth Amendment on if you wish. Kyle Moore asks, hey, so Grovium startup times are great, right? Cue the meme that we've all been seeing on the internet for the last year and a half. But what's the performance hit for AOT compilation?
Yes, great. That's actually a great question. So there is a huge amount of time that you have to spend ahead of time compiling an application into an ahead of time compiled application into a native application. And so what I do, I use Grovium native image in production on applications, and I never actually create the native image as any part of my development cycle. What I do is when I'm in local development, I am running on the JVM because that gives me instantaneous recompilation. We've been seeing that all night tonight. And then as part of my CI/CD pipeline, that's where I actually run the task to run native image to take my JVM based application and turn it into the native application.
Bake it when you're pushing it out to production. That makes total sense. Yeah, absolutely.
Now there is a risk to this because what you're running in production is not what you're running in development. And so there is now evolving ways to actually create your native image with your tests in it and run your tests against your native image so that you can verify that what you've created with native image is actually going to work when you get it to production. And so the tool space around this is evolving. Quarkus, again, has done a great job of moving really far ahead in this space. Micronaut is also doing a great job. Spring Boot is doing some of this stuff to do testing of native images as part of your CI/CD process. But the TLDR on that is do not use native image as part of your local development cycle. Put that into your CI/CD pipeline and put in as many things as you can to make sure that what you've created in your native image CI/CD pipeline is going to work like it did in development.
Super quick, James, I just want to say I really agree with you on the Quarkus. I think Spring is doing a lot of work with Spring Native, but the thing is there's a lot of reflection in their code base, from years and years of it. So they've got a pretty big job ahead of them You know, and this is me speaking as the former Spring guy, right? You know, so I mean, they've got a pretty big job ahead of them. They're doing great on it. I think Quarkus, you know, they've done like that has that's a very nice experience at the moment. Um, you know, I just don't think they used reflection as much. So there's less caveats and there's less exceptions to the sort of scope of the API surface that you can compile into a native image. And
Yep.
that, you know, that makes a big difference. I know the Spring team really well. They'll get there, but
Yep.
I'm just, yeah, I agree with you. I think Quarkus is delivering that right now. And it's funny, like, people don't know that. You know, I mean,
Right.
Quarkus is just sort of silently killing it in this particular aspect. So anyway, totally agree with you. And yes, we've had a bunch of people on Quarkus and not Micronaut actually. So thank you for reminding me. We've got to get a Micronaut presenter. But we've had Quarkus folks in 2021
Git Graham, he's
at
amazing,
SF
of
Java.
course. Yeah.
Yep.
I mean, I've used
James,
Micronaut, I've used
continue.
Quarkus, I've used Spring Boot, and there's certainly trade-offs to all of them, and they've all got really great things. But to your point, reflection is challenging when it comes to ahead of time compilation, because when you do ahead of time compilation, you need to know all the code paths, and reflection is essentially dynamic. And so you have to tell Grovium native image about the reflection points. And so you'll see that when I created my Grovium-ified version of this application, I had to give this type hint that says, hey, there's reflection happening here. And without that type hint, this actually throws a runtime error.
But my understanding was that like Micronaut was designed to not use reflection, right?
Micronaut actually does use the Kotlin, and you don't have to use Micronaut with Kotlin, you can use it with Java, but they use the Kotlin annotation processor, which is a compile time thing, a compile, not a compiler plugin, but a build plugin to do their weaving of dependencies together, and so that they don't do as much reflection as, but the whole JVM ecosystem has a lot of reflection in it. Jackson, the library that we're using for JSON, does a lot of reflection. Even very libraries in Kotlin that don't do much reflection end up using reflection in places. And so in the Scala world, and we're not going to have time to get too much into the Scala stuff, but in the Scala world, I do almost no reflection. And this is because the language has even more advanced features that allow me to do things that reflection is being used for in other places, or annotations are being used for in other places. And instead, I'm using other programming paradigms that don't use those same constructs. And so in most of my Scala code, there is absolutely no reflection, which means they are very compatible with native image, and make it a lot easier to do native image ahead of time compilation. Reflection, in my opinion, I wish reflection would just go away completely. Like, it's you can't do pure functional programming with reflection. Just they're incompatible things. And of course, as I state emphatically in my bio, I am a functional programming bigot. So
yes, Hugh is asking, does the Grovium community version, does the Grovium community version only provide serial garbage collection for the native image?
You know, that's a good question. I don't know, and maybe Alex can answer that one. There is a whole nother garbage collector and substrate VM that is in Grovium that gets used under native image applications, and I don't know a whole lot about how those actually work. There is the community edition of Grovium, and then there is the Oracle license version of Grovium, and I've used the community edition, and but yeah, I don't know all the details on what the differences are between those two different versions of Grovium. Good question.
This is normally where I would say, if someone can answer that, I'm going to send you a t-shirt. We don't yet have,
I would say contact your Oracle sales representative.
Oh, harsh.
Oh,
brutal. All right.
Is that a good idea?
Alex Buckley is actually saving us once again here. He says, yes, GraalVM CE is serial garbage collection. And if he recalls correctly, epsilon garbage collection. GraalVM EE adds G1.
Okay. So you get the G1 garbage collector in the Oracle license.
Very nice.
Cool.
Alex, thank
Good to
you.
know.
If I had
Thank you,
an
Alex.
SF Jug
Saving
T-shirt to
us.
send you, I would
God,
send
is
it
he
to you.
presented here at the jug yet? Because
You know, I mean,
he could just
if you
redo
can help
this
me sell 'em,
presentation and do it right.
it's hard to get Alex to come out of the woodwork to present on SF Jug. Alex, call me.
Okay. All right, so we've got our Grovium ified version of this, started much quicker and uses less memory, and that's all awesome and good. And thank you for all the questions. We've got a few minutes left, and I do want to show you one other quick thing before we wrap up, which is I've got this application called Kotlin Bars, and Kotlin Bars kind of takes some of the stuff to a step further. And I showed you already the Grovium native image part of this, but I want to show you the test containers part of this, because test containers is like it's up there with Grovium native image. It's in like my top 3 favorite things that's happening in the modern Java ecosystem. And so I want to show that to you because it's just awesome. So you may be familiar with in the Java ecosystem where we build database applications and we want to be able to run like an integration test against our database. And what we did for many years, and I'm sure many of us still do, is that we would use H2, a in-memory database that we could start up from our tests, and it was like mostly SQL compatible and all this. But the big problem with H2 is that it is not the same as what you run in production. And what ideally we want to do is when we're doing local development and when we're running our tests locally and when we're running our tests in CI, we want to be running against the database that we're actually using in production. And that's what test containers gives us the ability to do. So I have in this particular project, let's take a look at this. I have brought into here the test container for Postgres. So test containers is just this awesome new thing in the JVM ecosystem. And actually they now support Node and Go and other languages as well, but it really kind of came out.
So just for clarification, test containers are just for databases?
They're for really any external service that our application depends on. So when we're building something that depends on some external service, whether it's a database, whether it's Kafka, whether it's some other application, some other microservice that we're connecting to, we can use test containers to spin up that thing as part of our local development cycle, as part of our tests, as part of our local integration tests, as part of our CI tests, and use that. And so let me actually just show it to you so you can see what it looks like. So let's go over here to my Kotlin Bars repo, and I'm going to run my Gradle tests, and I'm going to force it to output the text to the console and rerun the tasks. So because by default, Gradle will be like, hey, you already run the test. We don't need to run those again, but we actually do want to run them again. So so this is running through this Kotlin Bars application, and you'll see that as part of this test that I'm running, this is my integration test, it is actually spinning up a Docker container for Postgres. So we can see, hey, we're spinning up Docker. Docker is all set up. Let's go spin up our Postgres container. So I'm starting up Postgres, creating the Postgres container, and then it runs my tests against my actual Postgres database. Now you can do this with Docker Compose. The difference is that with test containers, I actually control the lifecycle of my container that is managing these services. I control them in whatever way makes sense for my tests. Maybe there's some tests where I want to keep a container around for a bunch of tests because they're sequentially doing a bunch of things. Maybe for each test, I actually want to destroy the container and create a new one. And test containers randomizes the ports, so I could actually run those in parallel. All sorts of cool things that are happening here with test containers that are controlling the lifecycle of my service dependencies that are running as Docker containers. Now, what if you don't have a local Docker daemon that you can actually run these containers in? Well, lucky for you, the folks behind test containers just actually announced their startup last week called Atomic Jar, where they're doing test containers in the cloud. So you can actually, instead of using a local Docker daemon to run these containers in, you can use their cloud service to run these containers as well. So I love test containers. Every time now I start a new project that uses some external service, I use test containers for local development and for my integration tests that talk to that service. So yeah, it's awesome. With Kotlin Bars, you can, let me actually show you where this repo is so that you can go check out that in more details. There's more in there. It's a database driven application talking to Postgres, and the code for that is all up on this repo there on my GitHub, Kotlin Bars, and then in the branch Spring 1 is going to be the simplest version of this one. I think I've got one that uses like, I don't know, it's got like an Android client and a CLI and all sorts of other stuff, but the simple one that I just showed is the Spring 1 application. Oh, I didn't even show what the application looks like, which here, it's running on the cloud. Here's my database driven application, and there it is. I can go and add bars to a database. What are bars?
Okay.
I don't know.
That is
Bars.
super cool. Quick question. Wait, so is it if it was if the database itself was like serverless and auto scaling, like is it still the control that you need over the life cycle of the container that's running whatever database instance? Like what is it that you appreciate about it? I'm curious. Like you spent that long talking about
great
it.
question.
So I want to know.
So my dream world is, which is reality in a couple places,
Sure.
is that when I am doing local development, I'm using test containers. When I am kind of tinkering around or wanted to use pay as you go, then I'm using a serverless service. And when I am doing like full on enterprise stuff, then I can take that same thing and run it in Kubernetes. And there are today, I think, 3 services that you can run in that way. One is Kafka. So Kafka has test containers, it has a serverless offering, and it has Kubernetes operators. So I love it. Love Kafka. Just like it gives me everything I want. Cassandra now has the same thing. They've got a serverless offering, they've got a test container, and they've got a Kubernetes operator. And I think that that types Lightben's Cloud State, which was Cloud State, is now Akka Serverless, also has all 3.
Akka serverless, yeah,
Akka
exactly.
serverless.
Yeah.
So this is my dream, is like I want the test container for local dev and CI, integration tests and CI. I want the serverless offering, and I want the Kubernetes operator. Like, give me those 3 things for every service, and I am happy. So there are just a few of those that exist today in that realm. But yes, test containers are awesome. A huge thing that everyone in the JVM ecosystem should be using. Yeah.
You did it. Breathe. You did it.
We have a couple minutes left. We haven't even gotten into Scala yet.
Yeah, it seems like maybe that's for another time.
Can we do that in 2 minutes?
No.
Oh, by the way, James. By the way, I don't know if you know this, but DataStax is actually taking a position in Apache Pulsar. So
nice.
We are probably gonna, if I have anything to say about it, and I do, we will be having test.
Give me all 3 of those.
Oh yeah, I'm working on
awesome.
it. I will start actually.
Thanks,
just because
Peter.
you said that, I'm gonna start looking into it. Thank you.
Yes.
Great tip.
Yes. Okay, we have like a minute for questions.
We have more than a minute for questions. Apparently, your mention of Scala has not scared everyone off. There's still 36 minutes left, so if you want to get everyone to leave, you can start talking about Haskell.
Wait, how much time do we have left?
Gentlemen, you have the time that you need. It's fine. We still got plenty of folks on. There's great liveliness. Like, please take your time. You're fine.
Yeah, we.
If you want to keep going, audience, folks in the audience, if you want to ring the gong and go home, great.
I think what we should do is pitch our book, and give people like a little like this is going to be awesome, and then we'll take questions.
Okay.
Yeah.
Sounds great.
Okay, so Bruce and I and our friend Bill Fraser have been working on a book, which is, okay, we've taken some steps into the world of modern. If you want to take some leaps into the world of modern, Scala 3 and Zio 2, Zio is a Scala library. This is what our book is about, and it is futuristic. It'll blow your mind. We're working on a book around this right now, and it's cool stuff. Like, a lot of people have, I think, some bad taste around Scala from past experience. This is a whole nother world of Scala. This is it's so cool. But
is it a world without SBT?
Sorry.
Too soon.
Too soon.
Too soon.
We
Sorry.
are going to
Sorry,
use
too soon.
SPT, but
All
yeah,
right,
I mean
all right. Too
SPT
soon.
is
Too soon. Sorry.
Right,
Sorry.
yeah.
with that other tool, what's it called? The one that just builds,
cursor.
yeah, Corsair.
Cursor.
It that just
Yeah.
makes it much easier.
There's been some improvements in the SPT land,
yeah.
but we could use Gradle for our.
I think SPT is way better than Gradle.
Ouch!
They both have challenges.
Oh,
well, you can
The
go
burn.
read my blog post on the problems with Gradle or whatever it's called.
Okay, so quick 1 minute pitch on our Scala 3 Zio. We think that a better way to build software, more reliable software, more performant software, is by separating out the parts of your program that are pure functions, things that don't talk to the outside world in any way, from the parts that do talk to the outside world, creating an actual separation between those two. This paradigm is called effects or effect systems, and it allows you to do some pretty magical things when you create your program as a pure description of things that should happen, and then you apply the effects to them. I don't know. Give me your pitch on this, because mine's terrible.
Yeah. Well, okay. So pure functions don't break. Effects can break. So what we want to do is push the effects into a corner, put them in a box, so instead of
isolate them.
Instead of just having, the normal way that we have always programmed is like, stuff goes wrong all over the place at any time. What we want to do is take the stuff that can go wrong and, isolate it as much as we can and make sure that it doesn't escape into the rest of the program.
Yeah.
That's kind of what, and I've started thinking of Zio not as a library, but as a language within a language.
Yeah.
And I think that's actually a better way to think about it, because it changes. I mean, you're still programming in Scala, but you're programming in this different world in Scala.
Yeah.
And so it's, I think that's an easier way to think about it.
Yeah.
Yeah. So, I mean, anyway, the book is called Effect-Oriented Programming.
Yes.
And it's in the early state. I mean, we're still trying to figure out, what's the best way to explain this or that, and how
we're still trying to figure out what a monad is.
Oh no, I think I'm pretty happy with the monad chapter. No, I think the monad chapter actually does a really good job of,
I think so,
of saying what it is.
Yeah.
So, but yeah, it's under development, let's say.
Yeah.
James, after all these tweets, I thought you would have figured out monads. I really did.
Well, we've talked about it.
My Twitter bio says I cuddle with monads. Not that I understand them. Yeah, I cuddle with them. But,
yeah. Yeah. Well, once you understand them, they're very simple.
We always cuddle with the things we don't.
Monad.
Yes, that's the curse of the monad. Yeah. So.
Okay, Peter, are there any questions?
No, not the single one.
Okay. We probably, like, everyone as soon as we started talking about Scala, they're like, we're out.
Okay,
we're gone.
Push the department.
No, literally, we still have 35 people on, and I mean, that's about like 15 people less as soon as you mentioned Scala. So, but no, I'm just kidding. A good question from M. Gitman. He was curious if you could explain a little bit of the buzz around Zio in the Scala. Is it Scala or Scala? I've always heard Scala.
Scala. Yeah.
It is. Okay. All right.
Scala.
Just checking. I'm like, wait a minute. I have the authorities on the line. I should ask.
Yeah.
Zio. What's the deal?
So Zio is a framework for doing effects in Scala. And like we were just trying to explain very briefly about what effects are, but it's just a way to build more performant, reliable software more easily. And Zio is a really great library for doing that, or as Bruce calls it, a language within a language for doing that in Scala. And then Scala 3 adds in a whole lot of really nice language syntax that builds with Zio to create a really nice experience around building reliable performance software easily.
Yeah, the reliability is something that we're emphasizing. I mean, it's concurrency without the pain, but before you can do that, you have to have absolute rock solid reliability, which I think is something that we have been, or at least the argument that I've made is that for the last some decades, we've been focusing on how do we produce software faster, but not how do we produce more reliable software.
Yeah.
And so that, I think, is the, really what we're trying to get to with functional programming, is to be able to take rock solid, reliable little pieces and compose them into bigger pieces. And then eventually you get a program and it's reliable and refactorable and understandable. And if somebody wants you to add a feature, it doesn't, bring the whole thing to its knees. The whole development process. It's yeah, but it's a different way of thinking about programming, which I think there's a little bit of a hurdle, and what we're trying to do in the book is get you over those. It doesn't take you into the advanced world. We're trying to stay to the point where we're just getting you to understand things like, okay, what's a monad and what are effects and how do we compose pieces so that we can build programs that are reliable, and then enough examples so you say, oh, that's how it works, but we're not going to overwhelm.
Yeah.
This is not going to be like some of my Java books.
Yeah, so as an example of this, when you have a Zio, you can have any Zio, any operation in Zio, whether it's talking to a network, whether it's reading from the file system, whether it's like whatever operation you want to do. If it's something that can fail and you may be able to recover by retrying, all you do is you say .retry, and then you tell it the schedule that you want to give it for retries. Maybe you want to have exponential backoff. Maybe you want to have a limited number of retries. Maybe you want to, whatever. It doesn't matter. Like a Zio is a Zio, and you can do a retry on any Zio. And because we've separated out effects from the pure functions, we can just call retry on anything.
And when you're dealing with a concurrent system, that's always kind of been a, oh, we're not sure, we probably should just shut the whole program down and start it up again. Kind of like what they,
why not control alt delete it
in Elixir.
Right. Yeah, just let it fail.
Let pieces fail and just start them up again.
Yeah.
And so, it was always kind of the mindset was just, no, we don't, when you're dealing with any kind of concurrency, shutting down is not reliable, and reporting errors is not reliable, and it's just not something you could do. And so it kind of blew my mind when we started looking at Zio, and they say, no, we can do all that, and you don't have to suddenly go into this mode where you're trying to, this meta concurrency mode where you go, oh, let's see, how do we shut down a task reliably? It's like, no. And I guess that's one of the weird things about functional programming, or at least in this mode, is that it's taking all these hard things and it's extracting them into and making them part of this common space that Zio is going to take care of. So you just do the things that you want to do, and those bits are taken care of for you, which is a little hard to imagine.
This sounds slightly reminiscent of Circuit Breaker, like Hystrix in Netflix open source, or am I like, is that not compensating transactions?
Yeah. Oh man, we could open up that whole can of worms. But in the world of Zio, you are doing this in your program, and that's a big difference. Whereas in a lot of these other things, it's done externally. It's like, your Istio system can apply the retries. And what we're saying is no, let's build a program that knows how to handle recovery itself
Intrinsically, yeah.
intrinsically.
I see.
And you can apply different policies for different operations. And so, and retry is just one example of things that you can do in the world of effects. Like I have an example of racing two things, and you can do a race, and there's all these like higher level things that you can do once you have this foundation of effects. But retry is just a good simple example. So you put it into your program so that you can retry things differently where it makes sense. Maybe one, you want to limit the number of retries. Maybe another operation you want to do exponential backoff. Maybe another one you want to limit based on time. Maybe another one you want to, so it's, instead of externalizing that concern, Zio says, no, let's bring it into the program.
And make it a first-class citizen. Yeah, nice. Okay, that makes good sense. Yeah, because Hystrix was always like a remote service or something you had to. Yeah,
that's right. It's like a proxy. Like your proxy is handling recovery for you. And I'm of the opinion, like I don't want a proxy to handle that. I want that to be in my program.
Well, why stick a network call in between something if you don't have to for one? But so VJ asks how if you know how Zio compares with cats.
I've never used, well, actually that's not true. I use cats for one production application, and it works and it's great, but cats comes from a much more Haskell oriented approach. And so it never fully made sense to me because they have like the whole type class hierarchy of which matches the category theory of functional programming, and cats was a little too extreme for me. I'm a Java person, not a Haskell person. And so for me, Zio was much more approachable because it kind of looks like Spring dependency injection, and it kind of looks like things that I'm familiar with. And so
Sure.
I've been able to make cats work once for something, even though I didn't fully understand some of the concepes.
It's funny, we were threatening Haskell to,
and here we are. And now everyone else will drop off. Everyone's like, we're out. We're into category theory and Haskell, gone.
Well, one of the other things that Zio is focused on is programmer usability, being able to easily kind of just blunder your way into the right solution.
Kind of like Spring Boot. Yeah, it's like, just like get some good error messages and then realize what you're missing and throw the missing thing at it, and then it works. Yeah.
Well, and Scala 3 has tightened up some things so that the error messages are downright spooky sometimes.
Yeah, sometimes it's like, how did you know
how could it know that? Yeah. And that's quite an experience, because it could save, you can imagine saving a lot of time.
When it's all based on the type system. So dependency injection based on the type system, error handling based on the type system, and programs as values, which I don't know if I'm going to that, but it's all type based, like, and no reflection, no magic. It's all just types, and the compiler validates that something is going to work.
Right.
And with no reflection, that means you can all Grovium, right?
That's right.
So yeah, that's pretty sweet. That's a nice side benefit. Kyle Moore asks if pure functions in Zio lend themselves to atomic memo. I'm not sure if I'm going to pronounce this right. Maybe it's a typo. Memoization / cacheability.
Yeah, that's just
Could you correct me? What was
we can actually use from our podcast today. So we were talking to Richard Feldman, who created a programming language called Rock, and he gave us a really good definition of
what a pure function.
Yeah, which he took from somebody else who I don't remember.
Right. It's basically a pure function is something that you could imagine as being a map where you put in the arguments as keys, and the result is a value. And it might be a really big map, but it's the same. Well, it's
like a lookup table.
It's like a lookup table. You put in your arguments, you get the result, and because the result is always the same, it's basically, you could think of it as a map. And this is the idea. It's called referential transparency. It means it's the same as replacing the function with
the parameter, with the
lookup
value.
table. Yeah. with the computed value
Yeah.
with the lookup table.
Yeah, and we talked to Runar, one of the co-inventors of the Unison programming language, where they take this a step further, and they actually, to exactly this question, Unison actually globally can cache a given function with a given parameter value, and so that no one in the world should ever have to ever run the actual function again,
Yes.
given a parameter. Once one person in the world runs a function with a given parameter, no one else in the world should ever have to actually run that function with that parameter ever again. So they talk about the, like, one of the cool use cases is this is imagine cloning a repo, running the tests, and all of a sudden the tests just pass instantaneously because the tests know that every function with a given parameter has already been run. And so it's like, hey, we already know that these tests have passed. Like, and that's pretty cool.
Yeah, that's some really interesting
That's
things
like
going on there.
leaps forward in modern the world of
sounds
modernization.
Like caching take on steroids, man. I mean, that's like that's the dream.
Yeah,
right.
Always a cache hit.
The caching dream.
Well, right, and anytime you change the code in a function, it automatically becomes a new version.
In the world of Unison, yeah.
In the world of Unison, right.
Yeah.
But I mean, yeah, so it makes you really think about what is versioning anyway, you know, and why do we do it the way that we do? Yeah, no, it's pretty mind-bending.
Yeah.